All right, guys, let's do this. I'm going to do the first, all the problems from number 1, and then I'll do the first one on number 4, and then you guys finish this up at home. We'll do the rest of it on Wednesday. So we'll do the first 5 problems, A, B, C, D, E. And this kind of gets you to understand why a huge chunk of statistics is all about when is my distribution I'm working with normal enough. Because if it's normal enough, I know everything. I know everything. If it's not normal enough, I don't know shit. Oh, crap. And then you actually have to do what would be in a Stats 2 course, which we don't offer here. It's too bad for you. Right? So normally we're going to have... I'm going to have to create it so it is normal, right? But in the homework, you might have some that aren't normal. You just have to say, I can't do shit, and then go to the next one. Or, whatever, however you want to say that. So in the first one, I want the probability Z is less than 1.51. And by the way, I've had people that have extreme trouble making, and look at that, it's not even a nice curve. Make a freaking triangle, I don't care, right? It's just an anchor for you, a visual anchor, so you can put stuff. It just has to have low, high, low. That's all I care about. So I want the area below 1.51, so if I look that up, it'll be exactly the answer I want. So what area do you get? 0.9345? So on a test, if the test was perfectly normally distributed, the probability that a randomly selected student had a grade that was 1.51 standard deviations above the mean would be about 93.45%. The student would be somewhere in there. Right? You would be in this percentile of the class, right? The 93rd and a half percentile, just about. Okay, maybe. Let's see, part B. It's just a greater than negative 0.44, so I want it to be that. So if I look up negative 0.44, I get 0.33. So the area above it is 0.67. Or if you use the shortcut, look up positive 0.44, you get the 0.67 immediately. All right, good. I like it. C was the one with 2 ends to it. Here's 1.98, here's 3.21 negative. I want this area in there. And once you see this, it's very simple physically why it works this way. If you look up 1.98, what area do you get? 9761? Yes. And if you look up negative 3.21? 0007? So then the area in between those, subtract those two and you get? Yes. Right, you subtract 9761 minus 0.0007. Because if you subtract this much off, you'll be left with exactly what you want. What's in the middle. I like it. Okay. By the way, everything we're learning in Chapter 6 is the most important chapter in this book. Because almost everything up until Chapter 10 is its own dude. But everything else is going to rely on this kind of stuff. Some of you guys are like, oh good, that's easy stuff. And some of you guys are like, oh shit. You just got to get used to this. Part D is the first weird one. But some of you guys might notice, you actually already did this work. What does P33 mean? It's a really good first question. 33rd percentile. So it says find the z-score. So I don't know the z-score. So I can't look on the outside of the chart. I don't know what the hell the z-score is. That's in the 33rd percentile. So where is this z-score? Where is he? Is he up here? Down there? Because what's 0? What percentile is the mean in? 50th percentile, because half of it's below there. So 33rd percentile's got to be down here somewhere. So then it's only got a third of it below it, right? Don't put 0.33 down here. Z-scores go down here. This is 0.33 area. Now just to pretend like we haven't done a problem that deals with that, what you do on this kind of problem is you find 0.33. I look at the negative because I know it's below the mean. So you look at 0.33, try to find 0.33 in here. And the closest I can get is actually exactly 0.33. And that's a z-score of negative 0.44. Do you guys see that? So normally we look here and we go in, and if I'm given an area, I find the area and I go, wow. So this will be negative 0.44, and of course that's exactly what this was all about here. Right? You already found the 33rd percentile. All right, so what about part E? I tell you exactly how to set this one up. It's not a percentile. The z-score that has 5% above it. So where must it be? Below the mean or above the mean? It's got to be above, because if it has 5% above it, this has 50% above it. Shit, it's got to be way the hell up here, so it only has 5% above it. All right, so if you can't draw the picture correctly, you're screwed. So that's got 5% above it, so it's way up there. How do I find that z-score? Well, the chart only understands areas that are below. You're all like, let's see how many stuff you'll do for below. So this is going to be 0.95. If you look up 0.95, like we just did a second ago, and I know this is going to be a positive z-score. So if I look up what's the closest I can get to 0.95, it's a very interesting thing that happens. You see the little asterisk in the middle? Because this is perfectly symmetric around 0.95, so you just follow the little line. Z-score of 1.645. Because 1.64 has 94.95 below it. 1.65 has 95.05 below it. So 1.645 right in the middle has exactly 95%. So it happens a few times on there. You can see a couple of asterisks on there. And then the how are we doing on all this? I don't want to go too fast here. But I do want to do one from number 4. Let's do 4A. So this is, where it goes right in the middle for number 4. 31.64. Yeah, 31.64. And I want to know in part A, I want to know the probability is less than 27.2. What goes right below 31.64? 0, because it's 0 away from itself, right? Z-scores should go down there. So what's the very first thing I've got to do? And it asks me for less than this. So what do I have to do first? Yeah, because the z-score chart that I want to use, so I better make a z-score to use a z-score chart. So it's my score minus the mean. What was the standard deviation here? 7.81. Negative?
No. Oh, wait.
It better be.
I was negative 0.57.
Oh, you're somewhere else.
I was looking at
Negative 0.57? Oh yeah, this is one that is, so be real careful. Truly round these z-scores to 2 places, right? Some of you guys, if you want to, if you got 0.565, you could average 0.56 and 0.57, sort of like the asterisks do. If you want to. When I took this, we had to actually interpolate, find a linear function that went from one to the other. So I'm not going to make you guys do that. I'm not quite that evil yet. So that's negative 0.57, so how do I find this area? That's crazy. Oh yeah, just keep doing what you've been doing, Jeff. Oh yeah. Negative 0.57. I get an area of 2843. Which means if I randomly selected a student that parks here at Grossmont, there's a 28.5% chance almost that that student will take at most 27.2 minutes to find a parking spot on average per week. You with me? Hopefully that's not per day. Shit. It shouldn't be that bad anymore. It's the 7th week. So we should have weeded out enough students. It's still kind of bad? Not as bad as the first day. All right, so finish this up at home. We'll finish those next time.